Well, howdy there, Internet students. It's Mr. Hermanson again. This is the extra practice for Objective 1.2a, maybe we call it, or 1.2, whatever. But it's the one about slope. So you're doing this because you didn't do so well on that part of the test. Remember, you need to show the notes that I'm giving in order to get the retake, and then finish all the problems that I don't do, okay, accurately. All right. So first of all, what are two ways to define slope? I'm actually going to do it three ways. So let's first define it this way. The change, and then I'll show you some ways to do it. The slope is the change in y it's a ratio of the change in y over the change in x. Now, let's put that in terms you can maybe understand better. The change in y, and I'll put this on top, is going up, vertical. And the change in x is going across, horizontal. Now, on a graph, we just call the vertical change the rise. So how much are you going up? And that has to be a straight line up. And I know you're saying that's not a very straight line. And then the run is a horizontal line going across. Okay. Now, if you have two sets of coordinates or some data values, you can find that by taking two y coordinates and subtracting them, and then in the same way subtract the x coordinates to get the run. Now these numbers, these little numbers here, are just subscripts. They don't mean anything mathematically. This is just saying take the two y values, subtract them to get the rise, take the two x values, subtract them to get the run. All right? So if you have a set of coordinates, I'm going to use the formula that I just talked about to get it. And we usually use the letter m to represent slope, but the y values, I'll label them here, would be the 18 and the -2. So I'm going to do, I usually do the biggest one first when I'm doing the y values. That way that number is positive. Not that it matters. You could do -2 minus 18 if you want. Now, whatever order you subtracted the y's, you need to subtract the x's in the same order. So that would be my 5 first, and then my -3x. Okay, so 5 minus -3. And so that's 20. And that's 8. Now, a lot of times we like to leave our slope as a fraction. That way we can see the rise and run. It's a little more useful. So I'm going to just simplify this fraction. I noticed that 4 would go into both of them. So if I divide 20 by 4, I get 5. And 8 divided by 4 is 2. So my slope is 5 over 2. Now, there would be nothing wrong with dividing those and writing your slope as 2.5 if you want also. That just means instead of going up 5 for every 2 you go across, you go up 2.5 for every 1 you go across, which is exactly the same. Okay? But we usually like those to be whole numbers. All right. So you're ready to go ahead and do those problems. I'm going to continue the video lesson. If you want to pause right now and work on those, that's fine with me. Okay, now the next thing we're going to do is find the slope using a graph. Now this is where we need to find the rise and the run. To get the rise and the run, you have to locate 2 points. So like you might have noticed on this second graph that there aren't any dots on it. So you just kind of have to look for those where they're whole numbers. So I'm seeing dots right in those places on that one. You're going to do that one though, okay? So, so now I'm going to show you the rise and the run on this graph. The rise is between the dots how far up you go, so that would look like this little line right here. That's supposed to be straight up and down. And then the run would be the line that way. Okay, so you probably noticed that the rise was 1. I went up 1. And the run was 4. I went over 4. Okay, And since the rise comes first, we put 1 first, and then the run is 4, so that goes on the bottom, rise over run. But you also have to take note of the direction of the line. This line, since it's going down from left to right, is decreasing, which means the slope is negative. So this line goes up from left to right, so that slope will be positive. This line goes down from left to right, so that slope will be negative. All right. Now, to find the slope from a table of values, all you need to do is just choose two of these. Are really points. This is an x and a y, so a 0 and a 1 is one of the points. 1 and a 4 is another. And then you could do like you did on these problems up here. Use that formula. Okay. Now I just do it since I have a table. I just use the table and find the differences in the table. So you should notice that that this is going up by 3, right? And that's your 4 minus 1, which is the difference in the y values is the rise. Okay, and this is going up by 1 every time. And you can get that by doing 1 minus 0. That's your run. So my ratio is my rise over run, which would be 3 over 1. Now, usually when it's over 1, we just write that as a whole number, 3, because it simplifies to that whole number. 3 divided by 1 is 3. So all you have to do is pick 2. Notice this is going up 1 plus 1. This is actually going down 2, so we want to show that as a negative. All right, and you have all you need to do the slope. And so the y values is your rise. The difference in the x values is your run. So this slope is 1 over negative 2, or negative 1/2. All right. So you're going to find those slopes. Pause if you want. Now, sometimes slope is embedded in a situation, and we got to figure that out. So we actually have to think about what would be the y's and what would be the x's. So remember, x's are the independent variables. They're the ones that would continue and aren't affected by the other variable. Like Charlie's height in 2012 was 44 inches, and in 2018 was 65 inches. Well, the years keep going on, so a lot of times years are the independent variables. So those are your x's. And your y's are the heights. Okay? So, I want to find the change in the y values, which I'm going to do 65 minus 44 to get that. So in other words, how much taller is she over those years? And then the change in the x values is how many years did that happen? So annual means 1 year. So I want to divide by how many years it took to grow that far. Okay, so 65 minus 44 is 21. So she went up 21 inches in 6 years. Now if I divide that out, I actually get 3.5. So her height is changing over those years by 3.5 inches per year. Okay, so you could also write that like this: 3.5 over 1. That means 3.5 inches per 1 year, which is what we want for annual. All right, so go ahead and finish that up. Send me a nice picture of it, or turn it into a PDF so that I can check it, and then if it looks good, we'll get that retake to you. Good luck with that.